Welcome everyone to the ArcGIS Experience Builder session, Building Web Solutions, Advanced Topics. My name is David Martinez, and I'm a product engineer on the Experience Builder development team. And with me is my colleague Yue Ma.
Hello everyone.
Who is also one of our developers on the team as well. And with that, let's get started. So in today's session, we're going to go through the following. We're going to do a short intro of Experience Builder. And if this is your first session, we recommend you checking out our intro session of Experience Builder. Next, we'll go into some widget implementation concepts for creating widgets. We'll talk about data sources, and then we'll go into developing some message actions. Then we'll show you some tips on debugging. Then we'll switch gears. Oh, forgot, we got to talk about deployment. We'll show you how to deploy the app, and that's pretty straightforward. Then we'll switch gears and talk about more UI-centric development for widgets and themes. So what is Experience Builder, right? Well, Experience Builder allows you to create unique web experiences using flexible layouts, content, and widgets that interact with 2D and 3D data. Some of the benefits include complete control over the layout and design. In other words, one design doesn't fit all. For those who don't need that complete control, you can get started with templates that meet your most common workflows. And of course, since we're developers, we need that ability to extend in the event I need to add my own custom workflows. Now, Experience Builder has an extensible framework, and that's why we're doing this session today. And we use several technologies. And starting at the very bottom, we use TypeScript. It's our official language used throughout the builder. React is a library we use for building interfaces, and basically any widgets that you're going to develop are basically a React component. Redux is a predictable state container that helps manage app state in an app store, and we'll go into a little more details about that. Webpack is used for module bundling. We actually use Webpack to listen to any updates when you're developing your widgets, and then it packages it up and puts it in a distribution folder. And of course, we use the latest JavaScript 4x API. GIMU is a framework that you're going to use to extend Experience Builder. GIMU Core provides the interfaces and types to work with widget props, message actions, data sources, etc. It also defines several classes that will be used throughout your experiences. And a majority of you that are going to be working with Experience Builder, of course, you're going to be working with ArcGIS services. So we have a package called GIMU ArcGIS. It contains classes and methods for working with the API for JavaScript. And typically what's going to happen is you're going to use a GIMU map view and a GIMU map view component. The GIMU UI package includes UI components to be used in your experiences. And then the GIMU for Builder provides classes for developing the widget setting page. And then of course we have GIMU layouts, which allows you to do layouts as well. So let's talk about widget implementation, and let's discuss some of the patterns that you're going to go through. Now, by default, Experience Builder does not load the ArcGIS API for JavaScript when the app loads. And we've done this for performance reasons. If you need it, it loads. If you don't have a widget that doesn't, it's not going to load. So basically, there's two options to utilize JS API modules. Widgets that depend on the JS API, so like a widget that can almost do nothing without the JS API. You're going to declare that GIMU ArcGIS dependency in the widget's manifest JSON, and then you're going to import the module you need. For example, if you did something like import query, then you would do the require for Esri task support / query in your widgets.tsx. Widgets that depend on the JS API conditionally, for example, you could do something without the JS API. You would use import, load ArcGIS API modules, and then you could load the JS API modules dynamically to load the modules. Now, every configurable widget should provide a setting page to allow the configuration of a widget. In some instances, if you're building for yourself, you might not have a settings configuration page. But if you're going to be sharing it, we obviously do recommend that. It just gives you a better experience. However, in some configurations, it might be easier to modify settings on the widget rather than the settings panel. And in this workflow, a widget can support this feature by enabling inline editing. So basically what you do is you would declare support inline editing in the widget's manifest JSON under the properties object. And then in this instance, the widget would have an edit toolbar when the widget is launched in Builder. A good illustration of this is text widget. It's implemented this way. Another way is you can declare an embedded layout in a widget's manifest under the properties object. In this case, you would use a layout component to ensure users can drag and drop other widgets in and out of the widget. There are two components exported from the GIMU layouts, in the layout builder and the layout runtime. And then basically in your widget, you would need to use a layout component exported from GIMU layout/layout runtime to access the exported. The list widget is a perfect example that uses this technique. Other options to support inline editing is to declare context tool extensions in the widget's manifest JSON. This declared extension will be available in the selection toolbar. The image widget is used in this way. It adds it by adding a shape and crop tools in the selection toolbar. And to support inline editing, the widget might have some modules that are only required when the widget is launched in the builder. So in this scenario, you would basically place the modules in the builder-support TSX file. And this file should be in the same folder of your widget's TSX. The modules in this file will be available in this .props.builder support modules.widget modules. So that'll be available once a widget is launched in the builder. So let's go through a couple of demos, because what we did is we built this presentation to show you more code snippets and less sides. Okay, so what I'm going to go ahead and do is I'm going to go ahead and exit out my presentation here. I'm going to go into Visual Studio Code here. And the first thing I want you to notice is I've added the entire workspace of Experience Builder here. And basically, majority of your interaction in the builder is going to be in the client folder. And we have this extensions here folder, which is going to house all the extensions for your widgets and your themes. So what I want to do is I'm going to go down and I'm going to find this coordinate conversion widget here. And we're just going to go walk through this. So sometimes, for instance, you might be required to create a widget that may not be available in Experience Builder. It may exist in GitHub, or it's shared with you, or maybe it's available in the JS API. So we're going to go ahead and import a widget that's in the JS API and load it in Experience Builder. So the first thing that we need to do is we need to import the modules that we're going to use in the builder itself. So what we're going to do is we're going to just go ahead and walk through the process of uncommitting the code here, and we're going to import React module, the base widget, GIMU map view component, and then we're going to import the coordinate conversions from the JS API. Okay. The next thing that we're going to do is we're going to we're going to uncomment this interface. And basically what we're going to do with this interface here is we're going to basically use this to determine when the widget's loaded. So basically it's showing you how this illustrates how to initialize the state and set the state. So basically we're creating an interface of state, widget loaded is going to be a Boolean, okay? All right, so the next thing that we're going to do now is we're going to create our class for our widget here. And then basically we're going to use a type for all widget props. We're going to inject our interface for our state. We're going to declare the container for our API widget. We're going to use the interface for the concordant widget. And then here we're basically going to support either a map view or scene view. We're going to declare an Esri watch handle here. And basically here we're going to set initialize the initial state here. We're going to load it at false. Okay, and then we're going to continue on here. And next what we're going to do is we're going to we're going to activate some React lifecycle methods. Now these are out of the box. You don't have to do anything to wire these up when you're working in a class component. So let's just go ahead and comment these. And basically what this is going to do is this is going to do an unmount for our widget and basically destroy it to make sure that there's no problems there. And the next thing we're going to do is on our active view change here, we're going to basically load the widget to create the coordinate conversion widget based upon the map view here. So let's uncomment this. So basically on the GMU map view, we're going to get this map view, declare it to GMU map view, then we're going to create the API widget through this function here. And if it's this .map view, it's going to return. It will otherwise apply a coordinate conversion. It's going to initialize a coordinate conversion here. And then we're going to apply that to our view. And then we're going to put that in our container. Okay, so the last thing we need to do to make this wire up is we need to render this and output it for our display here. So we're going to pass this to our render, and we're going to detect, hey, if there's no map selected for this coordinate conversion, select a map. Otherwise, style the coordinate conversion, allow the user to do 100% height and width, and then basically allow them to select the widget ID for the map and then apply the active view change, okay? All right, so let's go ahead and save this. So the next thing that we need to do is we need to have a settings, because if we go into our widget, for instance, we go to localhost here, and I go into my Experience Builder. I'm going to go ahead and sign in. All right, so let's sign into my Experience Builder here. All right, so I'm going to go ahead and create a new experience. Let's go ahead and just do a blank full screen app. Let's just call this coordinate conversion here. Because what I want, by default, we have untitled for the experience name. So let's just call this coordinate conversion here. Let's hit, all right, so let's go ahead and find our coordinate conversion. Let's hit drag. You're going to notice that it's looking for a setting. So you're going to see this error here. You can see it says select map, but we can't do anything because we don't have anything embedded for the settings. So the next thing that we need to do is we need to go into our setting.tsx file, okay? And basically, it's the same pattern that you're doing when you're creating a widget, when you're creating a setting UI. It's similar with one exception. You notice we went into the settings.tsx file. So first thing that we're going to do is we're going to go through the same workflow. We're going to uncomment and import the modules we need here. And then the next thing we're going to do is we're going to define our class that we're going to use to export. So this basically says, okay, we're going to extend the base widget setting. We're going to support, so there's a supported types property, and this is going to be immutable for data source type web maps or web scenes. And then we're going to get instance of that and pass to the data source manager. And then on map selected, we're going to pass in that settings as a prop. And then the last thing that we're going to do here is we're going to render that based upon the GIM map view selector, that's a component of the map selected, and then use that for the widget's ID, okay? So if I go ahead, save, I go back into my experience, let's hit save here, and let's just hit refresh, okay? Okay, so now if I select here, perfect, there's no error now. So this widget is dependent upon a map. So let's go ahead and add a map. So let's add a map, and let's go and select one here. Let's go add new data. And let's just go ahead and select, let's just go with this one. And now that we have our map selected here, next thing we're going to do is we're going to select this one. And this is what we developed for the settings. We're going to select the map itself, coordinate conversion. And what we're going to do is we're going to preview this in live mode here. So now if I scroll into this map, you can see there's a coordinate conversion here. I can interact with this, and I can add a conversion if I wanted to, right? So simple demo, but very powerful because we've used the widget directly from the API. So if there's some widget that maybe we haven't developed, right? Like the print widget or something, right? you can just go in, grab that widget directly from the API itself, and then load that. And so if I go in here, I select map, hit save. Of course, I haven't collapsed or expanded my print widget, but here you can utilize a print widget to get a PDF output of this map, right? So very simplistic, but very powerful. It shows you that this widget is dependent upon a map. And that's what's unique about Experience Builder, right? Is that these widgets, you could select a different map. It doesn't have to be bound to this map because every data source can be unique, or it could be across the framework as well, okay? So, all right, so now that we showed you that, the next thing I wanted to show you is inline editing. Now, a little cool trick here, if you go to client and you go to distribution, which is dist, and you go to widgets here, so here's all my widgets that are loaded from my extensions. But if you look at these two folders, we have common and we have ArcGIS. Okay, ArcGIS is our map-centric widgets. We give you the source code for these widgets. So if I go into the text widget here, and I go into, this is the distributed source, so that's JavaScript. If I go into Runtime here, and I go into tools, you could see here it has the JS files, but also the TSX files, because it's distributed code and our source code. So if I go into the inline editing here, you can see where we declare this extension here, and then we get the default messages to pass, and then we provide the editing.csv icon, right? And if we go into our manifest JSON here, you're going to see within this array here, you have this inline editing context tool, and it tells you where this UI is for this tool, which is where we just were, right? So that's an example of how you would support inline editing from that. And if you want, you can check how that works by looking at not only the text widget, but you can also look at the image widget as well, that has these type of tools. So if we're going to do crop tools, it also shows you how this works. And then if we look at the same pattern for the extensions, it's basically the same thing. Here's calling the crop shape, the choose the shape, and then the crop tool. So now let's get back into our presentation. All right, so okay, so the next thing we want to do is I want to talk about data source, right? And at a high level, a data source has a schema, okay? Some records and may have a child-parent data source. In addition, every data source has a type, okay? Now, the data source basically defines how it accesses a widget. Data can be from a remote server, it can be stored in the app. It can be generated by a widget and used by another. So for instance, if I have a widget that imports, you allow people to paste a URL for a feature service. That widget's going to generate a dynamic data source on the fly. Data source instances and statusers are also injected into the widget, so you can use those. That widget can use the data source. And then, of course, a widget can have more than one data source. So when we look at a data source, it basically has interfaces, right? And the interfaces are defined in the GIMU core. And within that package, we have common methods and properties. So the ID is basically the data source ID, okay? And the type property is used to check the type of data source it is using. Every data source must implement the fetch schema method. Basically, it returns a schema. This is the schema that defines in for instance, the remote data service. So for example, when a user adds a data source in Experience Builder, the data source schema is not saved in the app config. It basically will fetch that. The get schema method basically is used by the widget to access the data source schema and fields in the data source. The get records method is used by the widget to access data records in the data source. And then we can use the get status to use this property to get the status of the data source. So some of these statuses include loading, loaded, and error. And then, of course, we want the ability to create custom data sources. So these can be created by the data source interface by extending the abstract data source class. Now, one thing to note about custom data sources is they're basically right today. There is no way to configure the custom data source in the builder. So if you have a widget and you want to use an external data source, the best practice is to use that external data source and inside the widget and fetch it directly. There's basically no need to wrap it into the widget itself, because in the builder it won't be able to allow you to do that. And then the data source is managed by the data source manager. So what are some of the main features for the data source? Well, it has the ability to share data between widgets. It provides a pipeline from data for data from one widget to another. And you can create data at runtime. And I'll show you an example of that. And then you can create a selected data source in URL to create a state for the URL. So if you have a certain data source, you can reflect that in the URL. And then the ability to change the data source, right? So we don't want it to break the app if that changes. And then what that allows you to do is the data source is reflected throughout our framework, or you can do it on individual widgets. It's totally up to you how you configure that. So how does data source use? Well, the data source, like I said before, it's defined how your widget accesses that data. And the use of a data source is declared in the app config with the property use data sources. The config JSON is going to be located in every server app, public apps folder, and I'll show you that. And in this snippet below, you could see here this data source has a couple different properties. It has web scene and web maps, and then it gives the item type and label and ID of that data source. So then, rather than me talking about it, let's go into some examples of some data sources. Okay. So one of the things with Experience Builder is your application necessarily doesn't have to have a map. Okay. So if I go back into my builder here, I'm going to go ahead and grab this widget called Count Features. It's going to tell me to select the data source. And here I have just simple text that says, okay, feature count, select data, and then I'm basically going to select US breweries. And basically what you're going to notice, it basically did a query, and it basically gave me a feature count. There's 3,939 records in here. And what do you see right off the back? There's no map, right? So what you can do is you could develop widgets that maybe just have a data source but don't have a map. Maybe it's some kind of query and it just shows some data source in a list, but there's no map dependency. And that's one of the beauties of what I like to think of features of Experience Builder. So what I'm going to do is let's go back into our extensions folder here, and we're going to show you how we built this simple count widget here. So let me collapse these and go into count features, and let's go into our widgets.tsx. Okay. So as you're going to notice, I have a little more imports than before because what I'm using is data record, data source. I'm looking for data source types. I'm doing a feature query data source. Okay. And then I'm also from the GIMU core, and then I'm also going to take advantage of using the ArcGIS package, which looks for a feature layer data source. So right off the back, what I do is I create an interface called iStates, and then I give it a property for source data to import these classes for a feature layer data source and query. And then basically what I want to do is I want to construct a query task, right? So here I have a let queue, and then I assign it a query of 1 = 1, object ID. So in this example, if I don't have an outfield on object ID, it's going to fail, right? So if you have something like a unique identifier FID and there's no object ID, it's going to fail. But this is just an illustration of how this works, so it's not really meant for production. But basically from here, we have this function query records, right? So we're going to inject properties for the parameter for all widget props, the IAM config, the data source, and it's a promise, and we're going to do a data source record represents a record in the data source. Okay, And then basically what we're going to do is we're going to detect what type of the data source is. Is it a type feature layer? Okay. If it is, and return feature layer data source, call this query count and do this query task, and then do the get records. Else, if it's a data source type of feature query, we're going to do a feature query data source. Now you might be thinking, why are you doing these two? Well, some instances might be, well, you might be working with a service that's an ArcGIS service, right? Or maybe you just want to query that data set. We have two different ways to query the data. In some instances, if you're going to work with a feature layer data source, or if you just want to query it, you can use one uses like the ArcGIS REST.js, and one uses the JavaScript API to do that. Okay, but I think the most important takeaway here is you can look for different data sorts and perform how your widget needs to behave, right? So if I go back into here and let's just delete this and let me re-add it. And then if I go here and I add new data, you're going to notice that it uses web maps, web scenes, feature layers, URLs, right? It's looking for everything in there. In some instances, when you work with the map view, it's only going to use the map widget. It's only going to look for web map or web scene, right? So it's up to you as a developer to detect that data source. So that's this is what these patterns show here. Okay, so here's where this is just before we get into the guts of our widget. So here we have our class widget off the base widgets, right? And then we do some preload here for our data. And then we return any query records here to use that particular data source. And then here we initialize the initial state for iStates, source data if it's undefined. Otherwise, this state equals the state object here. And then what we do is we pass that to the renderer features, and we do a feature count. And we look for if it's configured to get the record length, and then we're going to return that from the default messages, right? So if we go into our translations here in default.tss, we have this feature count here, okay? And now that's coming right here, so there we go. So there's our feature count. So that's coming from that translations file, okay? So if we go back into our widget here, the next thing we do is we pass that to our renderer, right? So if there's no data source detected, it's a common pattern. You're always going to look for a data source. If it doesn't, flag the user. If it's looking for a map, flag the user. Select a data source. Then we use the data source of that, and then we apply the source data to the state, right? And then we return that with the feature count. And then here's for our data source component to actually do the query based upon our source data. And then we use that data source of that. And then here we call the onDS function to do that data source creation. And then basically we bind those features to this to render that number, okay? So that's one example. Another example is, let's say you need to add records on the fly. So let's see if I have one. Yeah, here we go. Maybe I'll just grab this one. No, let's see, it wasn't. I wanted, maybe we could do this one, and let's go to home. So basically what I'm doing is I'm looking for a sample server here. I should have had this all wired up. All right, so let's grab this one here. All right, perfect. So let's grab, I don't know, maybe fire perimeter. All right, so let's grab this, Control C. So earlier I said you can create widgets at runtime. So here's a widget that basically is also dependent on a map. So let's go ahead and add a map here. And let's go ahead and select our old faithful brewery map here. Okay, and basically here we have a widget, and it's basically allowing the user to copy and paste a feature layer as a URL. And basically it's going to add that at runtime to the map, okay? So to wire this up, we need this widget to bind to this map. And the way we do this is we just declare map 1, and you can see we have settings in here that allow the users to zoom to layer on this. So if I hit, let's hit save, let's hit live view, let's paste in our URL here. Hope this works. Let's see, maybe, all right, let's see. It should be, oh man, I don't know. Hopefully it worked. Did it work? I don't know where the fire parameter is, but basically it should zoom to that feature there. Let me see here. Let's just do this one. All right. We'll have to come back to that one. But basically what it does is it adds the feature at runtime to that. So basically what's unique about this demo is we're loading the ArcGIS API modules as we need them, okay? Now let me show you a pattern of that. So if we go back into my add layers here, we go into my source, we go to my runtime here, we go to widget TSX, okay. So here you can see we're importing this thing ArcGIS JS API modules. Remember earlier I talked about if your widget doesn't solely depend on it, you can load this when it's needed. And that's basically what we're doing. So as if we look at this, same workflow, right? We're creating our class, extending base widget. We're loading our interfaces, and we have our types, excuse me. We also have another type here, and then we have our interface. And then basically what we're doing is we're going to give types to the modules we import from the API. And then basically we tell TypeScript which those are. So for our feature layer, this is using the Esri feature layer here, right? Query. And then we're going to pass in our state here, right? Because we're going to pass in the state earlier. And then every time the input box value changes, we're going to call this function here, right? So we're going to handle this URL, and then we're going to set that state, right? Because we got to reset that state if that target value changes. And then we're going to do a form submit on that value. And then if there's any errors, we're going to say, okay, data source is not configured. We can't do anything, right? Common pattern. And then if nothing was typed into the box, we're going to tell them, please copy and paste in a feature service URL. And this is what we call a term called lazy loading, right? Only loaded if needed. So this is how we load the modules. So we're here loading feature layer, query, and spatial reference, right? And then we're doing a promise of this dot feature layer, query, and spatial reference for these modules. And then we're going to create the feature layer from the URL that's in the box for this state.featurelayer input. And then we're going to pass that to the GIMU map view of the map, and then we're going to add that layer. And then after the layer is created, we're going to zoom to the layer's extent if the settings is set for that, right? So basically this is going to take the property configs. If it has that property zoom to layer, it should zoom to the layer, which is this Boolean of true, right? And then we're going to do a query here of that to get the spatial reference, and then pass that extent. And then lastly, we're going to set the state of adding the layer if we remove it from the box, so we can add another one. So that state's always going to be reflected and changed. And then lastly, this is pretty consistent with our other patterns. We're going to render that for that. Okay. So that's an example of creating a widget at runtime. Okay. So let's get back into our presentation here. So let's talk about message actions. Now this is a little different concept. So what is a message action, right? So a message action is a way to support communication between widget or widget to framework and framework to widget, right? I like to think of it as a message action as a way to send data from your application, right? It's going to send it somewhere, and basically it's going to be a store, right? And the only source of information is going to be in that store. And think of these, they're just plain JavaScript objects, right? And what we use Redux to help implement these message actions. And what does Redux do? It's basically state management using functional principles. All the application state is stored in a single store object. The state object can be read as an immutable object. And what we mean by immutable is that can only be changed by dispatching actions. So since it's immutable, you basically create a copy of it and create a new one from it. So how do we do it? Well, first, we start with an action, right? Which is basically an object, and you dispatch that to the Redux store. The action contains the data, the trigger that will be changed. Once the actions are dispatched to the reducer, right? This is just another JavaScript function. It determines what part of the store is changed. and it takes two parameters, the current state and action, and produces the state of an application. In this instance here, an extent change. So now that you have somewhat of a brief understanding of Redux, let's talk about how message actions work in Experience Builder. So basically, a message has a message type property, okay? And basically that indicates the type of action to be performed, such as an extent change or data record selection change. And the only action describes what happened, but it doesn't do anything, right? It doesn't describe how the application changes. So what will happen is a widget will call message manager to get the instance published message, and then in the parameters for the message, it will publish the message. And then when you're going to publish a message, the widget should declare that in the published message in the manifest JSON, okay? So let's talk about creating a message action. First, what you'll need to do is extend the abstract message action class. And in here, there are several methods and functions that will help you develop message actions. The filter message type method is used to filter the available actions. And in this code snippet, it returns message type string selection and data records selection change. The filter message method is just used to filter message in the message manager. We have managers for theme, for widget, for data sources, etc. And the get setting UR component is basically, you can use that to configure action based upon the message. So if you're going to be providing this to users, like in our example for the map, there's going to be some settings URI component to define what the action is based on the message. Okay. Continue on creating a message action. The onExecute method basically handles the logic for what you would like to happen for your message type. It basically selects the action based upon the message type, and it sends it from the application to the store using the getAppStore function, and then using the dispatch property. This basically what it does. It dispatches the Redux action and allows a state to be updated. Okay, so let's go into an example of how that works. All right, so if I go back into my browser here, and I go into, let's see, Experience Builder here, and no, we're going to go to local, host, and then we're going to do here. All right. Okay, so here we have an example. This sample demonstrates how widgets communicate, okay? So here we basically have three widgets here on the screen. So basically this widget will publish the string selection change message. So I'm gonna go ahead and select Colorado. This widget's gonna listen to the string selection change, right? And then it's gonna do the data record selection change message to do a query, okay? This widget will publish the data record selection message change to this widget. So we'll go ahead and select Montana here. You're going to notice it changed that. Same if I do Alaska. Okay, so this is an example of how messaging works. So let's go into our IDE here, and let's go into this particular widget here. So we're going to go into our extensions, widgets. Let me collapse this, and let's find our widget. So we have this widget called Subscribe widget. Now this widget doesn't have any UI for the configurations, right? So basically what's happening here is we import the modules we need, which is abstract message, message type, the message, getAppStore, app actions, string selection change, and data record selection change message from GIMU core, okay? Then we're going to define some interfaces here for the config for the change message. We're going to declare that field name. It's going to take a string. Another one for config feature change message, and that's going to be field name of a string and a query field name of a string. And here we're extending the abstract message, right? And then like we saw on our slides, we have filter message type, takes a parameter of message type, right? So you can see that's inheriting from an API reference here. You're going to pass in the message which ID, the string, and the Boolean. Then you're going to return the message type, which is a string selection change, right? And record selection change. And then you're going to find it within the index. And then basically you could see there. And then we're going to do the filter message for the message, the Boolean to return true. And here we're going to say, okay, for the getting component URI, it's going to look for this queried pass action. And then on the execute, right, method here, function, you're going to say, okay, Q, let Q equal action config for that interface we defined for query change. We're going to do the field name for the message, and then we're going to basically doing switch. So if the message type is a case of string selection, do this, get the field name. If it's for record selection change, query the field name and do this, and basically do a change record and get the data for that change message based upon that field name. And then what we do is we have to dispatch that to the store. So you're going to have your app actions, and this is where we're going to change the state of the widget for this widget ID within the query string, and then pass in the queue of whatever the case was from there, right? So that's how it works. So if we go into our manifest here, you're going to see that our manifest has message actions. The name is query, okay? And then the URI is actions query. So this is going to be the name of our action. So where we call it, it's going to be called query from there, and that's how that works. All right. So let's get back into our presentation here. Okay. Now what I want to do is I want to talk about debugging, right? Because let's face it, if we can't debug, we're pretty much hosed. So the first thing that you're going to do is, like anyone, is you're going to select your ID of choice. Our team pretty much uses all Visual Studio Code, and it's a great option because it has TypeScript built in by default, and it's great. It's open source, and it's the one that we use, and I like it a lot. But if you have one that's your favorite, you could use that as well. So the next thing you're going to do is you're going to add anything you do is going to be in that client folder, which I showed you before. You always want to make sure you add that to your ID workspace, because what that's going to allow you to do is reap all the benefits of IntelliSense. You can see the comments for API reference. You can look up definitions. And of course, it helps you with code completion, etc. So you always want to make sure you add that client folder at your workspace. And then we also recommend these extensions for Visual Studio Code. The first one's IntelliSense for CSS class names. This basically allows you to do CSS class name completion. And the last one we also recommend is the VS Code style components, and that's used for syntax highlighting for styled components. Okay, so let's go ahead and walk through a simple debugging exercise here, because I want to leave some time for my colleague here. All right, so let's go into Experience Builder here, and yeah, let's just use this one. Let's see. All right, yeah, let's use this one. All right, so let's go Command J here, and let's go into source. First thing you're going to notice is you're going to say, okay, you see this Webpack. You have Webpack running. That's perfect. All right, so what I'm going to do is I'm going to do Command P, and you're going to type in widget.tsx. And the one that you're going to want is the one that has the number with it at the end. Widget TSX, this one right here. Okay. All right. And then here what we could do is we could just go in here and say, all right, I want to do some debugging. So let's look at our state, see if this loaded here. And then we can see if this changed here. And we can see if the active view changed, right? All right. So let's just go ahead and refresh this. Changed. Oh man. Okay, hold on. Because I saved this widget differently. All right, so let's go back in here. Widget.tsx here. All right, so let's refresh this real quick. So here you can tell it's getting some information here. So if you look at the scope and you can expand this, you're going to have your local variables. And here you can see what's in here. Oh, it's a layout. It's going to tell you updated is mounted, the state. And then another important area is the globals, right? So these are globals that where Experience places a few of these. These are basically what I like to think they're convenience variables. So you can inspect the current status of different things in your Experience, right? So if I go ahead and scroll down here, I'm going to look for, let's see, down here, there should be some for widgets and data source manager. Yep, here we go. So here are some from here. You can see the App Store. You could see Data Action Manager, Message Manager. You can see all kinds of stuff here. And basically these, so if you look for Data Source Manager here, this one right here, basically that gets you the current data sources in the widget. And there's another one in here for Widget Manager, which basically, here's the Widget Manager. That will tell you a variety of properties about the widgets, including if a widget is loaded or not, okay? And then there's another one called Session Manager here. These are all global, and it basically tells you, you can see who's logged in from there, okay? So these are some just simple ways to debug, but as you can see all the dev tools. And of course, you can also add the React tools too, to look to see from a nested structure too, to see what the components look like. So the easiest way to deploy a project, Experience Builder, is I hit save and then I hit download, right? So download, so this appearance is not published. So basically you got to publish it, right? So publish is basically publishing it in your local instance of Experience Builder. And then you go ahead and you hit download, and then basically you download that package to your web server, and then you're ready to go. So with that, I'm done talking for the bit, and I'm going to turn it over to my colleague Yue.
All right, thanks, David. So in the following section, we will be focusing more on the UI development related topics. So first one, we're going to see how to develop and style the UI of a widget. In the second part, we will see how to create custom themes. So first, let's take a look at how to develop and design the UI of a widget. So normally there are 3 steps involved in creating the UI for your widget. First, you need to add the HTML structure to the widget. The HTML structure for the widget defines basically its layout and static content. Second, you may want to add CSS classes to elements in the DOM tree of the HTML template to either utilize existing global CSS classes, such as for background colors, font sizes, spacing, and etc., or to add a specific class name to an element in order to read any override CSS later. And the last, you might want to add the custom CSS styles to your widget. So next, I'm going to walk through these steps one by one, and follow that, we will see a live demo on how to create the UI for the widget. So first one is to create the widget HTML template. So the syntax that React uses for writing the HTML templates is called JSX. It is very similar to writing normal HTML, but with full JavaScript capability baked into it. The HTML code is usually defined in the return statement inside of a widget's render function. And one thing I would like to mention is that in Experience Builder, we provide a UI library for developers to use in their widget development, such as the basic UI components like buttons, drop-downs, inputs, navigation, modal, and etc. And also some of the advanced UI components, such as resource selector, expression builder, and in the future we are going to add more map-centric components. So you can utilize these GMU UI components instead of creating your own from scratch. And next, next is to add the CSS classes to the widget. And in React, the CSS class names can be added to the DOM elements through the class name attribute. Also in Experience Builder, we provide a group of utility classes, or you can call them modifier classes, to help you to quickly apply a style from the theme to a UI element. For example, you can add a class name called bg-primary to the container of your widget, to let it use the primary color from the theme as its background color. These utility classes follow the same naming convention as the ones from Bootstrap. For example, the background colors, text colors, borders, sizing, shadow, and etc. As seen in this screenshot here. Last one, which is to add the CSS styles. So, so there are basically 3 approaches to do so in Experience Builder. First one is to create a separate CSS or CSS file. And you can add the styles in those files and import the file as a module inside of the widget. This is more like the traditional way of writing CSS. Second one is to utilize the style attribute from JSX. This is very similar to writing inline CSS. You can define the CSS as an object and assign it to the style attribute on an element. The last one also, which is the recommended way to write CSS, is to use the CSS prop from Emotion, which basically is the way of using writing CSS in JavaScript. The reason is it is the most flexible and powerful way within all 3. And I'm going to explain this later. And by the way, in Experience Builder, it is also optional to include theme variables in writing your CSS for the widget. Utilizing the theme variables will make the UI of the widget to be dynamically updated with the selected theme and ensure the look and feel is consistent across the app. So theme variables are available as an object in widgets props. You can get it by typing this.props.theme. And the screenshot here shows a simple example of doing so. Next one is we're going to quickly see a demo on creating a widget UI. Right, so let me switch to the browser here. So I already have the builder open, and here I have a very simple demo widget added to the canvas. What it does is basically just you click this button and it's going to give you a random number from 1 to 20, and that's it. And it is only for demo purpose. And from the UI, you can see the UI is very simple. It doesn't have much styles applied to it. So in the code base, over here, within this demo widget folder, and within this widget.tsx file, here's the code we have for, so far for the widget. So at the top, we are importing the required components and modules from GMU core and the GMU UI. And we have a state that has a member called random number. So basically, we are updating this number when we click that button. And then the start state of this number is 5. And we have a simple function that return a random number to the widget. And over here within the render function, here we have a very simple HTML structure defined over here. It's very simple. It has a title, it has a heading tag that contains a number, and also a primary button from a GMU UI. So next, we are going to add some class names to the widget. What I'm doing over here is to basically add these utility classes to the widget. For example, we add the LED background to the widget. We make the text to appear as blue, which is the primary color. Then we add the padding, the shadow, make the text to be center aligned, and also some border radius. Okay, So if we save the file, go back to the app, then refresh the app. Let me log in again. All right, so you see the widget now has some predefined styles already applied to it. So now you can see the boundary of the container. And next, what we are going to do is we are going to add some CSS styles specifically for this widget by using the CSS in JavaScript, which is the emotion library from Experience Builder. So first one, we are going to do some required steps. First one is we need to include this JSX pragma. Then we are going to import CSS and JSX modules or classes from GMU core. Then we're going to actually going to write some of the styles. So over here, I'm going to declare a function which basically is going to return a CSS string. Okay, so as you can see over here, we are referencing the theme props from the widget. And over here, the first 6 lines of the CSS code is basically doing the same thing as the class name we have added over here. Then we add some extra styles to the button, which is to make it to appear as rounded. And also when it's hovered, it's going to zoom out a little bit. And the next one is a very nice feature from Emotion, which is that you can add logics in CSS already. Over here, for example, that we are watching the current random number. If the number is greater than 10, the text color will be green, and if not, it will be red. Then the very last step is to assign this function to the CSS attribute on the container of the widget. And by the way, we can comment out this class name part. So save. Let's go back to the app, refresh. Then we're going to see, okay, you can see now 5 is below 10, so it's appear as red. And if we click, okay, so 20 is greater than 10, so then it appears as green. Let's go back to the slides. So next one, in the following section, we are going to walk through how to customize themes in Experience Builder. Okay, taking a look at this chart, this basically explains the workflow of how the theme is applied in Experience Builder. Okay, so at the top left, we have the theme framework. It contains some of the core variables, including colors, font, border, and etc. Variables. And those variables are referenced by the component variables, which will be used in the style modules, which are functions that will generate CSS files on the fly. And those CSS files will be used by the actual UI components to apply the styles to the components. And since the widget is mostly composed with UI components, that's how the widget are adapting the theming from the framework. And as the demo has shown, that widget itself can also has its own style added to it. So how to do it? So basically, there are 2 approaches to create a new theme. First one is to override the default theme variables. The second one is to provide extra style modules or style sheets to the theme. First, let's take a look at how to customize a theme by overriding the theme variables. This is also the most common and easy way to create a new theme. In Experience Builder, there's a default theme that contains all the variables in the JSON format, as shown in the screenshot here. And in a custom theme, we can add variables overrides inside of the variables.json file. For example, we can change the primary color from blue to red over here. So at the runtime, the theme system will merge the custom JSON object with the default one and generate a new one for the app to use. So as you can see, when the custom theme is applied, the primary color has changed from blue to red. All right. The next two methods are to provide custom style sheets or style modules to the custom theme folder. So first one is more of the traditional way, which is to provide a separate CSS file in the theme folder. Basically, you can write any CSS styles in this file, and the file will be dynamically inserted into the head tag of the app. In this example, we add some simple CSS styles to the body tag to make its background to blue, text to red, and font to this impact font. All right, so this is the result of the theme after the style has been applied. Please note that in the CSS file, there's no access to the theme variables. So they are pretty much fixed values. And the next method is to define styles as modules. So instead of adding a style.css file in the folder, we can add a style.ts file in the folder. Similar to the Widget UI Demo, the CSS is defined within a function, and the function is exported as a module to the theme system to use. The good thing about this approach is that you can use all the theme variables from the system in your CSS writing, and also the styles created are scoped. So the example shown here is basically a rewrite of the same styles from the previous slide. But you can tell that the difference is that the styles will be changed dynamically according to the theme you selected. For example, this theme A has this blue background color and red text color. But when it is changed to theme B, those colors will be changed dynamically. All right, so at the very last, we're going to see a quick demo on how to create a custom theme. So let's exit. All right, so basically, let's show the demo folder here. So within your extensions directory, I have already added a demo theme folder over here. And within the folder, first, we have this variables.json file. In this JSON file, we are doing some simple stuff. First one is to change the primary color to red. Then we going to use a different font family, which is the Roboto we are going to add later, and make the font size smaller. And also we are going to change the primary button style to a different one. So let's go back to the builder. Using the same sample, if we select this demo theme, you can see that first the text colors have been changed to red, and you can see the primary button styles has completely changed. Okay, this is the power that overriding variables can give you. next one is we are going to work within this style.tss file. So first what we are going to do is we are going to actually import this custom font within this global styles function. So I'm going to uncomment this function and also this export. So what this export does is basically it's going to tell the theme system to use this function to apply the CSS as a global style. So save, go back to the app, let's refresh. Then we can see if you can tell the difference that the font family has changed to Roboto. And the last one I'm going to demo is to override the default styles for a specific component. The sample I'm using here is the button a component. So basically what I'm doing here is pretty much just change its font size to a bigger font size. And the same thing here, we are going to export this function as a module for as a style module for the button component to use. So save, go back to the app. Let's refresh again. You will notice the button has been bigger. So it's not only working on this button, but any other button components. For example, let's add a new button to the app. Then you can see the font size also becomes bigger. All right, so that's all for my part. Back to you, David.
Great. Thanks, Yue. So one thing before we go, I just wanted to redeem myself to show you that this demo works. So I'm going to go ahead and copy a feature layer here and add it, and should zoom to it, and there we go. So just needed to provide some redemption there. Okay, so before we go, we just wanted to provide you some valuable resources. First thing, always go to the developer website, Experience Builder developer website, to get the latest information regarding our technology. We have API reference, and we have links to sample snippets. With that, we have a samples repo for Experience Builder that will continue adding additional samples with widgets and maybe some config files to show you how other areas of our products work with extensibility as far as like data sources. So we'll include some code that might necessarily include UI because it's illustrating the concepts to use like data sources and other things. So stay on the look for that. And for those who are new to React or Redux, there's great information out there, much more in-depth and I believe valuable that I could teach you that you could find on there. And of course, we always want you to go to the GeoNet community for Experience, but we're always constantly listening to the channel and trying to answer questions as it may be. And with that, we'd like to thank you for attending this session, and hopefully you've learned something new. Thank you.
Thank you.